In this problem, we're going to be looking at the health of some workers in a company to see if it's changed from a previous generation. This company has data on the percentage of body fat that men had in 1995, and they found that it was 22%. Now recently, they randomly selected some men for the study and took some measurements and got some data for that allowed them to calculate the present amount of body fat in the population. So that's what we have here. We've got data for 12 different people, and we know that the past population mean was 22%. We want to find out if we can make a conclusion based on these samples of 12 people if the average on the whole company has changed or not. Now we might not be able to do it, or we might be able to do it. So let's look at this information that we have. Okay, we have, let's put down first of all that the population mean, that's percent body fat equals 22%. We've got the sample is n equals 12. N equals 12. And our hypothesis is, now this is, I think the prompt says this is middle-aged men, so we'll say hypothesis, middle-aged men in this company have more body fat than they did in 1995, and we can put the mean was 22% back then, so Control I and then M is the abbreviation for mean, turn the italics off, equals 22%. And this is a one-tailed hypothesis, so I'll stick in there one-tailed, because we're predicting that they have changed, that they have more body fat now than before. If we had said that they have a different percentage of body fat, that would be a two-tailed, but this one's a one-tailed hypothesis. Now, this is what's known as a single sample t-test, because we've got one single sample and we're going to compare it to a population mean. So the test is a single sample t-test. Let me turn the italics off for that. But there's no single sample t-test on the on Excel. So what we're going to use in data analysis, we're going to use the paired two sample t-test of means. And we've got to have this second column in here. This is mathematically, this is the easiest test to do. If you look in the textbook and see how the test is created, this is the one that they start off the chapter because the math is pretty simple, but we don't really have the command for it, so we have to, oops, I forgot, paired with a D. So we have to do a few things here. And one of the first things that we have to do is we just have to copy this 22 all the way down, so that's like we've got a score of 22 for each person in the second column. But that's just a little trick there. So we go to data analysis, and we're going to go to paired two sample for means. You go to OK, and the sample for variable 1 is going to be the top. So I'm going to I click on the top, Control Shift down arrow. I'll put this in for the variable 2 range. Click on the top, Control Shift down arrow. Hypothesized mean difference is 0. We always put that 0 there, and we've got labels. And it says, where do we want the output? I'm going to put it on this same tab I'll click in the box there, and now I will click here in K9, and I press OK, and it gives me lots of numbers. And let's make this a little longer, a little wider, I mean, so we can read. And so the mean percentage body fat is, now let me highlight this, is 25%. So it's higher than before, but we want to know if that's significantly higher. Let's get rid of those decimal points. There's a lot of decimal points there. I'll select that whole column and change that to number format. Okay. Now the number of observations, that's n, that equals 12. And our degrees of freedom are 11. And our t-stat is 1.65, which is not very high. So look at our p for a one-tailed hypothesis is 0.06. That's not very high. Let's see. Let's add another decimal point to it, see what it has. 0.064. So yeah, it's not close to 0.05. So we're going to say we don't have strong evidence that that men are fatter now than they used to be in this company. Now they might very well be, but we've got such a small sample size that we couldn't detect a significant difference here. So let's see, how are we going to write this up? We want it to be in APA format. I'm going to say the hypothesis that middle-aged men in this company have more body fat today than in 1995. That's when the mean, Control I, Shift M, Control I, mean equals 22% back then, was not supported. Next line I'm going to put the percentage of body fat in a sample. We can say n equals 12. The n goes in italics. We put spaces between and after, or before and after the equal sign. Okay, the percentage of body fat in a sample of n equals 12 was not significantly different than past measurements. And we can put that mean, Control I, Shift M, Control I, equals 25.50%. And then we report the t space. So I'm going to put the t in italics, Control I, T, Control I. Then right after the t, I put the number of degrees of freedom. I don't put a space. 11 in parentheses, not in italics. Space equals 1.65. And then we put the p-value, and the p goes in italics. Control I, P, Control I. Space equals 0.06. Close parentheses, period. So the hypothesis that middle-aged men in this company have more body fat than in 1995 was not supported. The percentage of body fat in a sample was not significantly different than past measurements.